Okay, so in the first part of Module 9, we looked at neurons, what they are and how they work. And we were getting ready to talk about the ways that drugs and other chemicals affect neural transmission. But before we get to that, I did want to go over this chart very briefly so you can see the different types of neurotransmitters and their function. So we talked about acetylcholine, which enables muscle function, learning, and memory. Dopamine, all of these other ones down here are the endorphins. Dopamine influences movement, learning, attention, and emotion. An oversupply of that is linked to schizophrenia, which we will talk about in one of the later modules in the spring semester. An undersupply is linked to tremors and decreased mobility in Parkinson's disease. Serotonin affects mood, hunger, sleep, and arousal. And an undersupply is linked to depression. Some antidepressant drugs can help raise the serotonin levels. Norepinephrine helps control alertness and arousal, and an undersupply can lead to a depressed mood. GABA is a major inhibitory neurotransmitter. An undersupply of that is linked to seizures, tremors, and insomnia. And glutamate is a major excitatory neurotransmitter, and it's involved in memory. An oversupply of glutamate can overstimulate the brain, which will produce migraines or seizures, which is why some people avoid things like MSG, which is monosodium glutamate in food, because they don't want to get an extra dose of glutamate. So how do drugs and other chemicals alter neurotransmission? Why not just flood our body with artificial opiates, since endorphins feel so good? Endorphins are meant to make you feel good. So why not just put a whole bunch of artificial ones in our body? Well, if we do, the body stops producing naturally occurring opiates. Then if we stop taking the artificial ones, say like heroin, the brain is deprived of all forms of opiates, causing intense discomfort. So drugs and other chemicals affect brain chemistry at the synapses. They either excite or inhibit the neurons firing. Against molecules may be similar to neurotransmitters and therefore mimic their effects. So some opiates are agonists. They produce a temporary high by amplifying normal sensations of arousal and pleasure. Whereas antagonists also bind to receptors, but their effect is to block a neurotransmitter from functioning. So for example, botulinum is a poison that forms in improperly cooked food, and it causes paralysis by blocking acetylcholine release. Curare is another example. It's a poison that some Southern American Indians have used on dart tips when hunting animals. So Curare blocks acetylcholine receptor sites on muscles, causing paralysis. Just a fun fact, small amounts of botulinum, like those used in Botox, are used to inject in the face to smooth out wrinkles because it'll cause temporary paralysis in your face. So if you've ever seen anybody who's had too much Botox and it's like they can't smile or make any type of facial expressions, that's why their muscles are actually paralyzed. So just to review how the neuron works. Neuron 1, so it's stimulated by its dendrites by our senses or a neighboring neuron. Neuron 2 then fires an action potential that starts in the cell body. That action potential travels through neuron 1's axon. It's sped up by the myelin sheath, and that action potential comes out of the axon terminals into the other or receiving neuron. So those out of the dendrites, you get the neurotransmitters that transmit the message from this neuron to the next. Okay, and before it can fire again, it has to go through the refractory period where it gathers up all of those positively charged ions that were allowed to rush in here in the center, and it sends them back out, and then those neurotransmitters that didn't get used in the next neuron come back, reuptake, they come back into this original neuron's axon terminals. Okay,